All right, here we go. We are doing the rest of the multiple choice questions that I assigned to you. So here's number 21. It says if g is a differentiable function such that g of x is less than 0 for all real numbers x, and f prime of x is x squared minus 4 times g of x, which of the following is true? And if you notice, all of the choices are talking about f. And they're talking about relative maxes and mins. So relative maxes and mins, we're going to look to f prime to tell us what's going on there. So we have f prime. We have f prime of x equals x squared minus 4 times g of x. So what we want to do is set this equal to 0. To find the critical values. So this would result in x minus 2 times x plus 2 times g of x equals 0. And then we would try to set each factor equal to 0. Here we would get x equals 2. Here we would get x equals negative 2. And for g of x, they told us something very important at the beginning of the problem. They said that g of x was less than 0. So that means that this factor, g of x, will never be 0. So the only critical values that we get will be at negative 2 and 2. And notice our derivative in its factored form, which we can use because it's equivalent to the derivative, is this. G of x is always negative, so keep that in mind when we do the sign chart. So I'll plug in a number to the left of negative 2, say negative 3. Negative 3 minus 2 is negative. Negative 3 plus 2 is negative. A negative times a negative times a negative is a negative. 0. 0 minus 2 still negative. 0 plus 2 positive. And g of x is always negative. So now we have negative times negative, which is positive. And then we have past 2, say 3. 3 minus 2 is positive now. 3 plus 2 is positive. And g of x is still negative. Positive times a negative is a negative. So now if we think about what f is doing, if we thought about what f is doing, on the interval negative infinity, negative 2, f is going down. Then f is going up. Then f is going down. So what we have is we get a max at 2 and a min at negative 2. Max at 2, min at negative 2, choice B. Number 22, it says, oops, this is a tough one, so stick with me on this one. What are all values of x for which the function f defined by f of x equals x squared minus 3 times e to the negative x is increasing? Increasing, decreasing behavior is predicted by f prime, so we will need to find f prime. So f of x is x squared minus 3 times e to the negative x. So we will use the product rule to take this guy's derivative. Derivative of x squared minus 3 is 2x. The derivative of e to the negative x, it's a chain rule application. We have e to the stuff. Derivative of e to the stuff is e to the stuff times the derivative of the stuff, which is negative 1. So now f prime of x is equal to, and by the way, this is just negative e to the negative x. So we would get 2x e to the negative x plus x squared minus 3 negative e to the negative x. So because of that negative sign, I will change this to a minus x squared minus 3 e to the negative x. So now, if I wanted to factor, because we want to set this equal to 0, so I'm actually going to factor this first, and then set it equal to 0. It doesn't really matter, but I want to talk about the factoring here. This is really critical. I want to take out an e to the negative x. If we do that, this is what we would be left with. We would be left with a 2x minus x squared plus 3. Just by naively factoring out e to the negative x. This is really not great because, first of all, the x squared is negative. I don't like that because I want a leading x squared to be positive. So what I'm going to do to fix this is I am going to take out a negative 1. So I'm leaving us with negative e to the negative x. The x squared will become a positive. The 2x will become negative. And the 3 will become negative. And now we have a nice, very factorable trinomial. with a leading coefficient that is positive. So f prime of x is negative e to the negative x times x minus 3, x plus 1. It's a bad negative x. Here we go. So if we set this equal to 0, sorry, getting ahead of myself, equals 0, if we do this, negative e to the negative x, e to any power can never be 0, so this has no solutions. Now be careful. Just because there are no solutions does not mean that this negative e to the negative x will not play a role in our sign chart. It will, because it's going to change the signs of things. So keep that in mind. X minus 3 is equal to 0, so x is 3. X plus 1 is equal to 0, so x is negative 1. So now I want to go to my number line. F prime. Again, f prime was factored negative e to the negative x times x minus 3 times x plus 1. E to any power is positive. So guess what? Negative e to any power is always negative. That's why I'm going to put a negative and circle it. That factor rather is always negative. So now we're going to pick a number to the left of negative 1, say negative 2. Negative 2 minus 3 is negative. Negative 2 plus 1 is negative. Negative times negative is negative. Now I'll pick 0. Negative e to the negative x is going to be negative. 0 minus 3 is still negative. 0 plus 1 is positive. Negative times positive is positive. Then, on the interval from 3 onward, e to the negative x is negative e to the negative x is still negative. Okay, 4, we'll pick 4. 4 minus 3 is positive now, and 4 plus 1 is positive. Negative times positive is a negative. There is my sign chart. So now let's take a look at what that tells us. What are all values for x so that f is increasing? Well, we're increasing on the interval negative 1 to 3. So between negative 1 and 3, the function is increasing. So we're looking at choice D. That's a hard question. Sure, the algebra is tricky. All right, number 23. The function f has the property that f of x, f prime of x, and f double prime of x are all negative. So if f prime of x is negative, that means f is decreasing. Whoops. If f double prime of x is negative, that means f is concave down. So if we draw our concave down curve for a moment, we want the decreasing portion of it. So I want this portion of it. And if we look, A does not satisfy that. B does. B is a sad-faced decreasing curve. C does not satisfy that. D does not satisfy that. And E does not satisfy that. So the answer is B. One other thing I want to make sure we understand here, f of x being negative means that the entire graph lies below the x-axis. So actually, if I were writing this question, I would have made one of the choices look like this. So for you to realize, this would be wrong because f of x is positive for certain numbers. This means that the graph must lie below, so f is below the x-axis the entire time, which choice B is. Number 25. If f of x is x squared e to the x, then the graph of f is decreasing for all x such that. Again, when we're talking about decreasing behavior, we're looking at f prime. So we have x squared times e to the x, so we'll set up a product rule. The derivative of x squared is 2x. The derivative of e to the x is e to the x. So we get the derivative to be x squared e to the x plus 2x e to the x. So now we have this function. I want to find out the critical values. Factoring out an x e to the x, we would be left with x plus 2. Okay. We have 3 distinct factors. X could be 0. E to the x could be 0, but that never happens. Let me actually just write. I'll write no solution. And then x plus 2 equals 0, making x equal to negative 2. And we need our number line. We can use the factored form of the derivative because it's equal to the derivative. So I can use to help us plug in, I can use x, e to the x times x plus 2. E to the x, that factor is always positive. Okay? So I want to plug in my critical values of 0 and 2. To the left of 0, I'll pick negative 1. Negative 1 is clearly negative. Negative 1 plus 2. Oh, I'm sorry. Scratch that, reverse it. Let me change this up. I meant to put negative 2 and 0 on the number line. See what happens when I do the movies and you guys aren't here to correct me and yell at me? Here we go. F prime and negative 2 and 0. That's better. Okay, let's try again, Mr. B. All right, so I'm going to pick negative 3. Negative 3 is clearly x, it would be negative. E to the x is positive. Negative 3 plus 2 is negative. Negative times a positive times a negative is positive. Then we'll pick a number between negative 2 and 0. Let's try negative 1. X being negative 1 is negative. E to the x is always positive. Negative 1 plus 2 is positive. Negative times a positive is a negative. And then past 0, say 1, x becomes positive. E to the x is always positive. 1 plus 2 is positive. Now we have positives. So we are decreasing on the interval negative 2 to 0. Choice B again. 28. An equation of the line tangent to y equals x cubed plus 3x squared plus 2 at its point of inflection is. Well, at the point of inflection, we need to find y double prime. So that necessitates us finding y prime first. 3x squared plus 6x. And y double prime is 6x plus 6. Finding a point of inflection would require us to solve that equation. So 6x is negative 6. X is negative 1. And we want to write the equation of the line tangent to that at the point of inflection. So the point of inflection, we know our x coordinate's negative 1. Tangent line equation, y minus y1 equals m times x minus x1. Well, we know the x value now is negative 1, so this will become x plus 1. The slope will be gotten by plugging in that x value into y prime. So if we want to find the slope, so that would be 3 times negative 1 squared plus 6 times negative 1, which is known better as negative 3. And if I want to find y1, I need to go back, for y1, we need to go back to the original. So at negative 1, we get negative 1 cubed, which is negative 1, 3 times negative 1 squared, which is 3, plus 2. 3 plus 2 is 5, minus 1 is 4. There we go. And now we have to transform this to look like one of the answers. So here we go. Y minus 4 is equal to negative 3x minus 3. Add 4 to both sides. Y is negative 3x plus 1. Looking like choice B again. Number 29. At what values of x does this function have a relative max? Relative max, we need to look at the first derivative. F prime of x is 15x to the 4th minus, I think we maybe done this in class, this equation, minus 15x squared, setting this equal to 0. Factoring out of 15x squared, we would be left with x squared minus 1. Factoring further, x plus 1 times x minus 1. X could be 0, x could be negative 1, x could be 1. So, number line time, f prime. I'll use its factored form because the factored form is equal to the original derivative. 15x squared, x minus 1, x plus 1, negative 1, 0, 1. Plugging a number to the left of negative 1, say negative 2. 15x squared will always be positive, except at 0. Negative 2 minus 1 is negative. Negative 2 plus 1 is negative. Positive times a negative is a positive. Plugging in a number between negative 1 and 0, I shall choose a negative half. This term stays positive. Negative 1/2 minus 1 stays negative, but negative 1/2 plus 1 turns positive. Positive times a positive is a negative. Between 0 and 1 will be positive 1/2. So the x squared term still stays positive. The 1/2 plus 1 term still stays positive. And the x minus 1 term stays negative. 1/2 minus 1 is negative, so that interval is still negative in terms of the first derivative. And then past 1, I'll try 2. So the first term stays positive. 2 minus 1 is positive. 2 plus 1 is positive. Positive all the way. And now relative max. If f prime is positive, that means f is increasing, then decreasing, still decreasing, and then increases. So we want a relative maximum that would occur at -1 only. So choice A. It's A this time. Sneaky. All right. One more. 31 says, let f be the function given by f of x is 2x e to the x. We want to find out where the graph is concave down. So that'll necessitate the second derivative. So second derivative requires us to get the first derivative. So here are our constituents. Here are their derivatives. We'll put them together. 2x e to the x plus 2e to the x. Now we have to take the second derivative. Now notice something. We just took the derivative of this, 2x e to the x. It was 2x e to the x plus 2e to the x. Whoops, sorry. Here we go. The derivative of 2x e to the x was 2x e to the x plus 2e to the x. I also need to take the derivative of the 2e to the x. So I need to take that derivative. Well, the derivative of e to the x is e to the x. The constant can just come along for the ride, so we get 2e to the x. So now f double prime of x altogether, nice and neat here, is 2x e to the x plus 4e to the x. Set this thing equal to 0. Factor out a 2e to the x would work nicely. We'd be left with x plus 2. 2e to the x equals 0 produces no solutions. X plus 2 equals 0 lets x become -2. So on our number line, this is an f double prime number line. We're going to use the factored form of the second derivative because it is equivalent to the actual derivative. It's not some sort of derived equation from it. So before we get, first of all, 2e to the x is always positive no matter what. Before we get to -2, say -3, we're going to be negative. So positive times a negative is a negative. 2e to the x is always positive. Now we'll choose a number to the right of -2, say 0. This will be positive. Here we are, positive. So we want to find out where this function is concave down. It'll be concave down when the second derivative is negative, which is for x less than -2. So we're looking at choice A. Last but not least, number 32 says the graph of y equals f of x is shown in the figure above. It says on which of the following intervals is the first derivative positive and the second derivative negative. Please don't get confused. These are derivatives. So they're saying if you want to translate, f prime is greater than 0 and f double prime is less than 0. So that would mean that the function f is increasing because they gave us a graph of f. And this would mean f double prime less than 0 means f is concave down. So if I draw a sad face, a concave down curve, and I split it in the middle, the increasing portion would be this portion. So I'm looking for any part of the curve that matches that curvature, and that would look like the part from B to C. If I kind of stretch this thing out, you know, something like this. Yeah, I'm not going to match it perfectly, but you get the idea. This part here is increasing concave down. So from B to C only, A to B would be increasing concave up. C to D would be decreasing concave down. So B to C is the only interval that works, 2 only. And I believe that's a wrap. Yep.